Chapter 1.3, Day 1, we're looking at modeling with linear functions. So first, we're going to review how to write linear equations. Now, for a given slope, m, and y-intercept b, we're going to use slope-intercept form. And remember, and it tells us here already, but m here, that's multiplied to the x, that is our slope. And b is our y-intercept. That's where it hits the y-axis. Now, if we're given a slope and just a point, then we're going to use point slope form. And then, so how that looks like is it's y minus y1. So remember that the y's are grouped together. So y1, y minus y1 equals m times x minus our x1 right here, x sub 1. Okay, so point slope form, and then we convert it to slope intercept. Okay, so what we do is we multiply and so forth to get slope intercept form. Now, given points, if we're just given 2 points, x1, y1, and x2, y2, then what we're going to do is first use the slope formula to find the slope, m. Then we use point slope form, the point slope formula with either given points. You just choose one of them. So remember that the slope formula is y2 minus y1 over x2 minus x1. So just remember the y is in the numerator. It's always y on top. That's your rise. And then the x's are your runs. So now we're going to write a linear equation from a graph. The graph on the left shows the distance asteroid 2012 DA14 travels in x seconds. So first we want to write an equation of the line and then interpret the slope. And then the asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance, which is, we want to know how long does it take to travel 17,200 miles. So first, let's write an equation. That's the first thing it's asking for. Write an equation of the line, and then we'll interpret the slope next. So what we want to do is we can find a slope in one of two ways. We can use the slope formula, or we can use rise over run. Now, because this is really 0, 0 here, it's kind of fast. You could just do up how many and right how many to figure out the slope. Or let's just practice using the slope formula. So x1, y1, x2, y2. And so this is going to help us find our slope. The slope, remember, is right up above here. And so I'm just going to plug it in. y2 is 24, this number here, minus y1, which is 0, over 5 minus 0. So make sure you don't mix those values up. So it's 24 over 5 is our slope. Now in this case, I'm going to go ahead and convert it to decimals. And so if you plug it in your calculator, you'll get 4.8 is our slope. So that's number 1. Next thing we know is our y-intercept. So I did say it here. It hits the y-axis right at this point at 0, 0. So our y-intercept is 0. Or I'm just going to write it as an order pair 0, 0. We do know the slope and the y-intercept, so therefore we can use the formula y equals mx plus b. So we can plug it in. So y equals our slope is 4.8 times x, and then our y-intercept is plus 0, but we don't necessarily need that there, right? Plus 0 is fine. So that's the first part of writing equation of the line. We did get that. Here is the equation of the line given the graph. Next, we want to interpret the slope. So we want to know, what does 4.8 mean? And so what that means is the asteroid travels 4.8 miles per second. So as a hint, because we are going to get some practice in writing an equation of the line, interpreting the slope, really take a look at the table that you're given. So number 1 is talking about an asteroid. Number 2, the distance. So the slope is telling us that this asteroid is traveling, and we have 4.8 miles, and then per second. Okay, 4.8 miles per second. That's what this means here. So use the words on the table to help you in interpreting slope. So that is A. Now let's look at B. About how long does it take the asteroid to travel 17,200 miles? So if we look at our equation here, the x is going to, what does the x represent? The x represents our seconds, and then the y represents the total distance. And so therefore, if we know that we're looking at 17,200 miles, which value does that represent? Which variable does that represent? Well, 17,200, because it has to do with distance, that's going to equal our y value, right? So what we're going to do is we're going to take this y and plug it into here. Take the 17,200, plug it into here, and we're going to solve for x. And another hint is it says how long does it take? So we're solving for the time, which is our x value. So lots of things to look at to help us discover what the question is asking us to do. So let's plug in the y. Y is 17,200, and I'm plugging it into our equation, 4.8x. So now let's solve for x to figure out how long does it take the asteroid to travel that far. And so we get x equals 17,200 over 4.8. When you plug that in the calculator, that is approximately 3,583.33333, so it goes on forever, seconds. Now, 3,583.3 seconds, that's okay. But we really want to find out, like convert it to some other time. So seconds, we know we can convert that, right? 3,583.3 seconds. If that's seconds, we want to convert it to minutes, right? So every 60 seconds, that's 1 minute. And then for every 60 minutes, that's 1 hour, right? So we're doing a dimensional analysis. Maybe you remember doing this in your Algebra 1 class, or maybe even in chemistry. So we cancel it out. And then what you will find, so 60 times 60, that is 3,600. And so notice it's 3,583.3 over 3,600. That's pretty close to 1 hour, right? That's pretty close to 1 hour. So we can say that it takes the asteroid about 1 hour to travel 17,200 miles. Travel. So that is part B. Now I'll have you try this one down here. So write an equation of the line of the graph shown on the left. And then B, interpret the slope in Y-intercept. What is the remaining balance after 36 payments? So we have 3 things we're going to take a look at. Now, just as a hint on here, we have balance in thousands of dollars, and then we have number of payments. So I'm going to change the balance of thousands of dollars. This represents our Y value, right? So this is our Y value. So in thousands, that's going to be our Y. So let me just change that. So this is 18,000, and then here this is 15,000. To kind of help you with the number of payments and so forth. Now this is just in, single digits, or they skip, but this is just in normal numbers, right? It doesn't say hundreds or anything else. It's just the number that it says. So that is just 10. The only thing that changes is the Y to help you out. So try this. Use the slope formula to try and find the slope. Write your equation of the line, do the interpretation, and find the remaining balance after 36 payments. All right, so if you tried this out, so first to find slope, I just did the slope formula. So this is my y2, x2, y2, x1, y1. So 18,000 minus 15,000 over 0 minus 10. And so it should be a negative value because the slope is going down, right? So it's a negative slope, so that should make sense. And so I had 3,000 over 10, and that reduces to negative 300. And so I knew that, and then the y-intercept, I could just look at the graph here. It labels it for us, which is excellent, and it's 0, 18,000. So I wrote my equation, y equals negative 300x plus 18,000. Now the negative 300, what that represents is the payment on the car loan. So how much are we paying each time? And then the 18,000 is the beginning balance of the car loan. And then C, we want to know what is the remaining balance after 36 payments. So we're trying to figure out remaining balance, which is our Y. We know we've made 36 payments, so that is our X value. So X is 36. So we plug in X is 36 into the equation, and when you do that, you find that it is $7,200. And so the remaining balance is $7,200 after 36 payments.